Hello my dear students, once again welcome to your online class. Hope you had a great vacation. Now it's time to come back to your virtual classes again. So today's class will be studying about the 7th chapter of your physics textbook, that is the chapter sound. You already know the basic concept of sound, that a sound is a form of energy which is produced by the vibration of a body, and this energy, it produces the sensation of hearing in our ears. Just like the light we have, the light is that form of energy which produces the sensation of vision. Similarly, what does the sound do? The sound, it produces the sensation of hearing in our ears, and basically the sound is produced by the vibration of a body. What is vibration now? The rapid to and fro motion of a particle or any object is known as a vibration, which you have already learned in class 9 as well. So now in the reduced syllabus, you have a very less to study in this chapter. So these are the points that we'll consider in this chapter. What is it? We'll learn the reflection of sound, which is known as a echo, uses of echo, the 4 kinds of vibrations, and the characteristics of the sound. So to begin with the reflection of the sound, echo, just like whenever a ray of light is incident on a mirror, it's reflected back into the same medium. So in the same way, the sound wave, what happens? When the sound wave, it strikes a large surface or a large obstacle, it is reflected back. So the sound heard after reflection is known as a echo. Just like if you stand in front of a mountain cliff and then if you shout your name, okay, you must have seen in the movies the people shouting in front of the mountain and then they hear the sound again. So that reflected sound. So the sound, it travels to the air. So this huge obstacle, it reflects back the sound again. So this reflected sound is known as a echo. Okay, so now there are certain conditions to hear an echo. You must be thinking that in a room, or like if you are standing in front of the wall and if you are speaking, we do not hear an echo. So it is because something known as the persistence of hearing. Okay, so we have persistence of hearing, which means that if the two sounds reaches our ears in the interval of less than 0.1 second, then we hear only the first sound. We do not hear the reflected sound. Okay, so that is known as the persistence of hearing. Okay, so the persistence of hearing, it states that there must be an interval of at least 0.1 seconds between the original sound and the reflected sound. Only then we can hear an echo. So in a room or when you are standing closer to the wall and speaking, what happens? Obviously the sound goes towards the wall and it gets reflected back. But why don't we hear an echo? Because the original sound and that reflected sound, it reaches to our ears in less than 0.1 second. So we hear only the original sound, we don't hear that reflected sound. Okay, so it is the incapability of a human ears. Okay. So that means there must be a certain distance between the obstacle and the source, so that when the sound comes back, okay, the time taken by the sound come back is at least 0.1 second or greater than 0.1 second. So let us try to find what is that minimum distance required to hear an echo. Okay, so this may come as a numerical problem in your board's exam as well. Okay, so we know that suppose there is an obstacle. Okay, so this is a huge obstacle, a person is standing there. Okay, so let the person be standing at a distance of x meters. Okay, and then he makes a sound or he creates a sound. So the sound travels x meter and then it also has to come back x meter. Okay, so that he may hear an echo. So the distance traveled by the sound will be distance traveled by sound will be equals to 2x. Why? Because the sound has to go also and it has to return also. And it is found that the speed of the sound in air is usually taken to be 340 meters per second. Okay, so now using the formula of speed equals to distance by time. Okay, so I can easily find the distance will be equals to speed into time. Okay, so speed, how much is the speed? Is 340 meter per second. Now into time, what is the time? The minimum time required to hear an echo is 0.1 second. Okay, now this d the distance traveled by the sound is how much? The distance traveled by the sound is 2x. So replacing this d by 2x. So this implies that x will be equals to, now multiplying 340 into 0.1 second, it gives me 34. Okay, so coming to, so it's divided by 2. So 2 1 is 2, 1 goes there, 2 7 is 14. So therefore x equals to 17 meter. Okay, so this is the first condition to hear an echo. That means the distance between the source and the obstacle must be at a minimum distance of 17 meter. Okay, so this is very important from your examination point of view. So apart from this condition, the first condition, there are other conditions as well to hear an echo. So the first is, yes, obviously the first condition to hear an echo is the minimum distance between the source and the obstacle, it must be 17 meter. And the second is the size of the obstacle, it must be larger than the wavelength of the sound. Okay, like if you are standing at a distance of 17 meter and you are just whispering. Okay, obviously the third is the intensity of the sound, okay, or the loudness of the sound. The sound must be large enough. Even if you are standing 17 meter away from a certain obstacle and you are just whispering, you will never hear an echo. So therefore, the second condition to hear an echo is the size of the obstacle must be large. Okay, like it should be a mountain cliff or a huge wall or a tall building. And the third one is, what is the third condition? Yes, the third condition is the intensity of the sound or the loudness of the sound you produce must be enough that it may not fade away in the air itself. Okay, so because it has to travel through the air and come back to the ears also. So the three conditions are: the minimum distance must be 17 meter, the size of the obstacle must be greater than the wavelength of the sound you produce, and the third one is the intensity of the sound also must be large enough. That means the sound should be large enough. So that is all about echo. Now coming to the uses of echo, the echo is used in a sonar system. Okay, so it is known as a sonar. Okay, what is the full form of sonar? It is the sound navigation and ranging. So using this principle, okay, like what to do, usually in the ship, in the navigation field, the ship, it has a transmitter and a receiver. Okay, so to find the depth of the sea, so what does it do? The transmitter, it sends the sound wave, okay, and the speed of the sound wave is known, and then there is also a receiver. Okay, so it receives the sound, so it also records the time interval in which it hears the reflected sound. So the time is also known. Okay, the time is known, and then the speed is also known, so easily the distance can be calculated. Okay, so using the principle of echo, especially in a navigation or a sonar system, it's utilized to find the depth of the sea or any obstacle below the bed of the sea, or yes, it's also, even it can also be used by a fisherman. Okay, so if there are fishes, okay, so if there are fishes within the water, so the sound is reflected back by the fish. Okay, after striking the fish, it reflects back. Okay, so in that case also, the fisherman, they can easily find out what is the size of the fish and how deep is the fish inside the water. Apart from this, the principle of reflection of sound is also used in a medicinal field. You must have heard ultrasonography. So in that, usually the ultrasound is sent through the human muscles and it strikes through the internal organs and it reflects back, and then it's shown in a screen. You must have seen. Usually it's done in case of like whenever you have certain defects inside your body, or usually when women are pregnant. So the unborn fetus or that womb, that baby, is usually seen with the help of this reflection of sound, which is called USG or ultrasonography. Now coming to the next topic, that is the types of vibration. So there are usually, the vibrations are usually classified under 4 types. Natural vibration, which is also known as a free vibration. Okay, so the natural vibration is also known as a free vibration, the damped vibration, the forced vibration, and the resonance. So let us try to understand each one of them individually. So the natural vibrations are the periodic vibration of the body in the absence of any external resistive force. Okay, so and these kinds of vibration it takes place only in a vacuum. So that means it's an idle case. So in this case, there is no resistive force. Like if you make a pendulum swing, okay, the pendulum swings forever with the same amplitude, but that is not possible on this earth. Okay, it may be possible if you go into the space or if you go in a place where there is no air. So any vibration of a body, the periodic vibration of the body in the absence of external resistive force is known as a natural vibration. So if I have to represent it graphically, the natural vibration with the time, so what happens? So this is a natural vibration. Okay, so with the time the amplitude remains constant. Okay, so what does the amplitude means? The distance from the mean position here. Suppose if this is x, the z, this also remains x, and this one also remains x, and throughout. Okay, so but this is not possible in a practical life, because we have seen that whenever something moves, obviously it comes to rest. So that is not a natural vibration. So in a natural vibration, what happens? The amplitude remains constant in the absence of any external periodic forces or external resistive forces. So what happens? Generally in our day-to-day life, whenever something vibrates, we see that it eventually comes to rest. It's because of the resistive force. So the damped vibration is the practical vibration that we see in our day-to-day life. So the damped vibration is the periodic vibration that takes place in the presence of external resistive force. So in case of external resistive force, what happens? The swinging pendulum, okay, eventually its amplitudes decreases and finally it comes to rest. So the damped vibration, graphically it can be represented like, initially the amplitude is large, okay, but with the time what happens? The amplitude becomes larger and larger and finally it fades and comes to rest. Okay, so this is the damped vibration. Okay, so the damped vibration is the periodic vibration that takes place in the presence of external resistive force. Now coming to the forced vibration. Okay, so in case of a forced vibration, if the pendulum is swinging or if somebody is playing a swing, okay, swing, in Dasera time you must have played that, what is that called? Lingeping. Okay, so if somebody constantly pushes it, what happens? The body, it can attain the same amplitude provided the frequency of the external force you are applying matches the frequency, the natural frequency of that swing. Okay, so in case of that force vibration, you can also draw the same graphical representation. So how to define? The force vibration is the periodic vibration that takes place in the presence of externally applied periodic force. So in a force vibration, you externally applied the periodic force so that the body moves with a constant amplitude. And damped vibration, its amplitude decreases because there is a resistive force. So you must understand, okay, in the damped vibration the resistive force acts, but whereas in the force vibration the externally applied periodic force acts there. Okay, so in that case you can either increase the amplitude or decrease the amplitude in case of the force vibration. Now coming to the resonance. Okay, so what is resonance? The resonance is the special case of forced vibration. Okay, so like when your friend is playing that swing, which we generally call in Nepali or Lingeping. Okay, so when he exactly come at a certain point at the extreme position, and when you push him, what happens? He moves a little bit higher. Again he comes back. Okay, it goes a little bit higher. You push it in the time being. Okay, as soon as he starts moving the other side, you push him. He will go more higher. Okay, so that is the resonance. So to define the resonance, you have to say that. So the resonance is a special case of force vibration in which the frequency of an externally applied periodic force exactly matches with the natural frequency of a vibrating body, and the body will start vibrating with the increased amplitude. So that is known as a resonance. So in case of a resonance, what happens? The amplitude goes on increasing like this. Okay, provided the frequency of the externally applied force and the natural frequency of a vibrating body, it must match. Now there are some consequences of the resonance. Okay, like you must have seen a hollow guitar. Okay, so in a hollow guitar there is a wooden box. Okay, like if you see the difference between the electric guitar and a hollow guitar. Now electric guitar, if you play it without plugging it into the amplifier, the sound is not so loud. But a hollow guitar, the sound produces the larger one. It's because of the principle of resonance. How? That hollow box, it contains the air inside it. So when the strings vibrate, what happens? The air inside that hollow box also starts vibrating. So in that case, the sound will be amplified, or it becomes a louder one, larger. Another example of resonance is, yes, usually when the army troops, they march past. Okay, usually on the bridges, what happens? They are told to break down their march. Okay, it's because if you have been to the bridge, okay, and if you are walking, when the truck passes by, the bridge, it vibrates. Okay, so by chance, unfortunately, if the frequency of the bridge, it exactly matches with the footstep of the army, what happens? The bridge will start vibrating rapidly with the increased amplitude, and the bridge may collapse. Okay, so there are many examples of resonance in your book. You may learn it yourself. Now finally, coming to the last topic, that is the characteristics of the sound, which you have been learning in your junior classes as well. So there are three characters of the sound: the loudness, pitch, and the quality. So what is the loudness? The loudness is that character of the sound that helps us to differentiate between a loud sound and a faint sound. For example, the loud sound, when the train honks, okay, it produces a loud sound, and when a scooty honks, it produces a faint sound or a lesser sound. So the loudness of the sound, it helps us to differentiate between a loud sound and a faint sound. And the loudness of the sound, it depends upon the amplitude. Okay, so the loudness of the sound is directly proportional to the amplitude. The greater is the amplitude, the larger is the sound. Okay, so if you have to compare, in exam you may be given the graphical representation like this. Okay, like this. So in this, which is the louder sound? The one with the larger amplitude. Okay, so we see that the amplitude here, the displacement is greater than in the, suppose if this is case A and this one is case B. So the B is a fainter sound than the A, because the amplitude, the loudness of the sound, it depends upon the amplitude. Okay, so remember that. Now coming to the second character of the sound, pitch. Okay, so what is pitch now? The pitch is that character of the sound that helps us to differentiate between a flat note and a shriller note. Okay, so what is a flat? Flat is also known as a bass. Okay, like a pitch, a high pitch and a low pitch. Okay, usually the male, they have a low pitch, the flat voice, and usually the women, they have a high pitch, which is also known as a shriller. Okay, so the pitch, it helps us to differentiate between a flat and a shrill sound. So the factor on which the pitch of the sound depends is the frequency. So higher is the frequency, the shriller will be the sound. So now the two sound having the same loudness, okay, we can easily differentiate it. Like loudness, I draw this one. Okay, so in this case, so this is A and B. So though the amplitude in both the cases are same, the loudness is same, but here I see that the number of waves making per second is greater in A. So A is shriller and B is a flat sound. Okay, so the shrillness of the sound is directly proportional to the pitch of the sound is directly proportional to the frequency of a wave. The higher is the frequency, the shriller will be the sound or the high pitched. Now the third character is the quality. Now the quality of the sound is that character that, like if the two sounds having the same loudness also and the same pitch also, okay, but we can easily differentiate it. Okay, like for example, your mother and your mother's friend, if they are speaking in another room, you will easily be able to find out which voice is your mother's and which voice is your auntie's. Okay, so what helps us to differentiate? In this case, the quality of the sound is determined by the waveform. Okay, so waveform means the formation of wave may be different kind. Okay, like some may be a square waveform. Okay, some may be a triangular waveform. Okay, some may be a sinusoidal wave, like this kind. So it depends upon the types of the waveform. Okay, so the quality of the sound, it helps us to differentiate between the two sounds having the same loudness also and the same pitch also. Okay, so and the quality of the sound is determined by the waveforms of the sound wave. So that's all that you have to study in this chapter, the sound. Please go through the reduced syllabus and each of the examples, and also go through the details in your textbook. And still if you find problem, you are free to ask me in my WhatsApp number. Thank you.